For as long as humans have looked up at the night sky, we've been haunted by a question. Not what's out there, but how far can we really go? Each star we see is a sun of its own, shining from unimaginable distances. And somewhere among them might be another Earth, another home. But here's the catch. In the cold, brutal mathematics of space, distance is merciless. Even our fastest probes are crawling when measured against the vastness between stars. So the question isn't if we'll ever go, it's how. Could we actually reach another star within a single human lifetime? Let's find out. Our journey begins with the closest possible target, Alpha Centauri, a triple star system just over 4.24 light-years away. That's 40 trillion kilometers. If you wanted to drive there in your car, even at highway speed, you'd arrive in about 50 million years. At light speed, the trip would take a little over 4 years. Sounds manageable, right? But no human spacecraft has ever come close to that speed. Voyager 1, the farthest object we've ever sent into space, travels at around 61,000 kilometers per hour. At that speed, reaching Alpha Centauri would take over 75,000 years. That's the entire span of human civilization, repeated 4 times. Even light itself, the fastest thing in existence, takes over 4 years just to get there. Every beam of starlight that hits your eyes tonight began its journey before the pandemic, before the latest election, before your last cup of coffee cooled. And that's just our nearest star. This is the cruel truth of interstellar space. It's not just far, it's almost impossibly far. The speed limits of today. Our rockets are magnificent, but also painfully primitive. Chemical propulsion, the same basic technology that powered Apollo and the space shuttle, is wildly inefficient for interstellar travel. It burns fast, it's loud, it's spectacular, and then it's over. After a few minutes of fiery acceleration, the rocket's spent. What follows is decades of slow, silent drifting. The fastest spacecraft humans have ever built, NASA's Parker Solar Probe, reached an incredible 690,000 kilometers per hour as it dove past the sun. But even that record-breaking speed is only 0.064% the speed of light. If Parker somehow held that speed all the way to Alpha Centauri, it would still take nearly 7,000 years to arrive. Clearly, rockets won't cut it. If we want to reach another star in one lifetime, we need to think far, far beyond fire and fuel. Enter the dreamers and the engineers crazy enough to listen to them. One of the boldest concepts on the table right now is called Breakthrough Starshot. It's not science fiction. It's a real privately funded project proposed by physicists, engineers, and even Stephen Hawking himself. The idea? Use powerful ground-based lasers to propel a fleet of tiny, ultralight spacecraft, each about the size of a computer chip, attached to reflective sails no thicker than a human hair. These Starship probes would be accelerated not by rockets, but by pure light. The laser array would fire for just a few minutes, pushing the sail to a staggering 20% of the speed of light. That's about 60,000 kilometers every second. At that speed, Alpha Centauri could be reached in roughly 20 years. There's a catch, though. At those velocities, even a grain of dust could obliterate a probe. And once it arrives, there's no way to slow down. It would streak past the target star system in a blink, collecting data as it flies by, and sending it back home years later. But here's the thing. Even if we never build a human ship that fast, projects like Starshot prove one thing. The barrier isn't imagination, it's engineering. Nuclear and fusion dreams. If light sails are the minimalists' approach, the big thinkers dream much bigger and much louder. In the 1950s, a group of scientists came up with something that sounds completely insane. Project Orion. The plan? Detonate a series of nuclear bombs behind a spacecraft to propel it forward, riding shockwaves of atomic explosions through space. It could, in theory, reach 5% the speed of light, meaning Alpha Centauri in under a century. But politically and practically, it's a nightmare. No one wants to fill space with nuclear fallout. So the idea died on the drawing board, but its physics remains sound. More elegant is the concept of fusion propulsion, harnessing the same reaction that powers stars themselves. If we could control sustained fusion and direct that energy efficiently, a fusion-driven craft might cruise at 10% light speed, reaching another star in 40 to 50 years. That's within a single lifetime. The technology? Still decades away. But it's not impossible, just unfinished. Even if we could build such a ship, there's another twist. Time itself wouldn't flow the same way for those on board. Einstein's relativity tells us that as you approach the speed of light, time slows down relative to an outside observer. To people on Earth, your voyage might take 50 years. But for the travelers inside, depending on their velocity, only a few years might pass. In a sense, the universe has already given us a loophole. The faster you go, the shorter your trip feels. The journey across the stars could literally bend time for those brave enough to make it. So maybe humans don't need to go first. Maybe we start small, really small. Imagine a swarm of laser-propelled nanocraft, each carrying sensors, cameras, and microprocessors the size of your fingernail. They're cheap, redundant, and almost weightless. If one fails, 1,000 more follow. Each probe beams back images as it streaks through a distant star system at 1/5 the speed of light. No humans on board, no risk, just pure exploration. That's not science fiction anymore. That's what Breakthrough Starshot is literally designing today. It's humanity's first credible path to interstellar space. Not with rockets, but with light itself. Still, we can't help but ask, when will we go? Could we ever send people, not machines, to another star? Some scientists suggest generation ships, enormous, self-sustaining habitats that drift through space for centuries, with new generations born and dying aboard. Others imagine cryogenic voyages, where humans sleep for hundreds of years in stasis, awakening in a new system. But here's the problem. We can't yet keep a single human alive in deep sleep for a month, let alone a century. And even if we could, who decides who goes, who stays behind? And what happens when you arrive at a world that might already be lifeless, uninhabitable, or claimed by time itself? It's not just a technical problem, it's a philosophical one. The truth is, interstellar travel is as much a test of what we believe about ourselves as it is about physics. The future of interstellar hope. Despite all the challenges, one thing is certain. We've already started the journey. Right now, Voyager 1 continues to drift farther from Earth than any human object ever has. Its golden record, containing the sounds and images of life on our world, is our first true message to the stars. It's slow, painfully slow, but it's proof that humanity is capable of dreaming beyond its reach. Maybe the first starship won't carry astronauts. Maybe it'll carry AI. Maybe the next great leap won't be a rocket launch, but a breakthrough in quantum communication or propulsion physics or something we haven't even imagined yet. Because if history tells us anything, it's this: every impossible frontier eventually falls. We once said humans would never fly, never reach the moon, never send a probe beyond the sun's influence. And yet, here we are. So could we reach another star? in a human lifetime? Not today, but maybe tomorrow. And when that day comes, when the first message arrives from another sun, it won't just mark a new era of exploration. It'll mark the moment humanity finally took its first true step into the galaxy. The stars aren't unreachable, are just far away. Every light in the night sky is a reminder that distance is temporary, but curiosity is eternal. So keep looking up, because the story of how we reach the stars has already begun. If you enjoyed this journey, subscribe and join us again for more cosmic adventures right here on Skyward Space Quest.